In this video, I'm going to create a function in C to replace all occurrences of a substring in a string with another substring. So we could use this function to replace all occurrences of a word in a string with another word, or to replace all occurrences of a phrase in a string with another phrase. And we'll call this function replace because it's pretty similar to Python's replace function. So the first thing we'll do is include a couple libraries to help us. We're going to include the stdlib.h library, because this library includes the malloc function, which will allow us to dynamically allocate memory to store the new string we're going to create. We'll also include the string.h library, because this library includes several helpful functions for working with strings that we're going to use in our function. And our function will look like this. We'll say car star replace, and it will accept the arguments car star before, car star old sub, and car star new sub. So the function is going to accept as an argument what we're going to call the before string. So the string before making the replacement. It's also going to accept as arguments the old substring that we're going to replace in the before string with the new substring. And what it's going to return is the new string, the after string, after making the replacement. So we'll copy and paste this, and we'll provide a definition of the function down here. Now the way our function is going to work is that we're first going to have to figure out how big does the after string have to be after making the replacement. Because let's say, for example, I've got a string like this. The cat chased the mouse. If I wanted to replace the word the with the word a, the after string would look like this. We'd say a cat chased a mouse. And the after string would be 4 characters less than the before string. If we wanted to replace the word the with the word that, the after string would look like this. We'd have that cat chased that mouse. And now the after string is 2 characters larger than the before string. So we have a situation here where it's possible that our after string will not be the same size as the before string. And that's possible if the old substring does not have the same length as the new substring. Because if we said here, maybe Y cat chased Y mouse, and we replaced the with Y, then the string does have the same length. But we have to be prepared for this possibility that the after string does not have the same length as the before string. And so what we're going to do is figure out how many times does that old substring occur in the before string. In this case, it occurs 2 times. And what we're going to do is multiply the number of occurrences of that old substring by the difference in length between the old substring and the new substring. Because in this case here, the old substring is 2 characters larger than the new substring. We have 2 extra characters, right, between the and a. And then we have 2 occurrences of the. So 2 times 2 gives us a difference of 4. And that's why this after string is 4 characters less than the before string. In the case of the word that, now our new substring is 1 character more than the old substring. And we still have 2 occurrences. So 2 times 1 gives us 2 characters more that we need to allocate in terms of space for our after string. So we're going to have to do some math here to figure out the size that we're going to have to allocate for our after string. So the first thing we'll do is figure out the lengths of the old substring, the new substring, and the before string. So we'll say int old length is equal to, and we'll say strlen old sub. So strlen is a function that comes with string.h, and it finds the length of a string. It does not include the null terminator though, and we have to be aware of that. So it's going to get the length of the old substring, and we're going to store it into old length. And we'll do the same thing with the new substring and the before string. So we'll say int new length is equal to strlen new sub, and then int before length is equal to strlen, and we'll say before. So now that we have the lengths of the 3 strings, what we're going to do is figure out, is there a difference between the old substring length and the new substring length? If there is no difference, allocating space is going to be somewhat easier. So here we'll say car star after, and we're going to use after to allocate space for our after string. And we'll check, if the old length is equal to the new length, then there's no difference in size between the before and after strings. And we'll allocate space like this. We can say after is equal to malloc, and we'll say before length plus 1, and we'll multiply it by the size that it takes to store a character. So we'll say times size of car, which should just be 1, but we'll do that anyways. So what we're doing is allocating enough space to store all the characters in the before string plus 1 more for the null terminator. And then we're multiplying it by the size of characters because we need space for that many characters. Characters should just be 1 byte, but that's okay. We'll just do this anyways. So this should allocate enough space to store the after string when it's going to be the same size as the before string. Next, we're going to handle the case that they are not the same size. So here we'll say else. And then here we're going to have to loop through the before string and figure out how many times does the old substring occur in the before string. So here we'll say int occurrences, because we're going to have a variable to keep track of how many occurrences there are in that old before string. We'll make a variable I to keep track of our index in the before string, because we're going to loop through it basically, looking for the old substring. And here we'll say while I is less than the before length. So until we've reached the end of the string, keep going. And here we're going to use another function from that string.h library. We're going to say if str and before I, and then as the next argument, old sub is equal to and before I, then do this. So what we're doing here is we're checking at the current index I in the before string, if the first occurrence of the old substring is at that same position, then we're going to do something here. And what we're going to do is increment occurrences by 1, and we're going to increment I by the old length. So what this is checking for is, have we found the old substring at this index in the before string? Because the way the str function works is it's going to return a pointer to the first occurrence of this string in this string. And what we're doing here is we're providing basically the before string as an argument from the index I onwards. And it's going to return a pointer to the first occurrence of that old substring. Now, if the first occurrence of that old substring is this position we're at in the string right now with index I, then we found it at that position that we're at right now with the index I. And we'll increase the occurrences because we found it. And we're going to increase I by the length of the old substring because we can now skip over that many characters while checking through the before string. If we didn't find the old substring at this index I in the before string, then we're just going to increment I by 1 because we want to check for it at the next character in the string. So let's just go over this briefly, just because I think this is a bit tricky here. So let's say we did have the cat chase the mouse. And let's say we were looking for the substring the as our old substring. Initially, I would be 0, and we start checking for the right here at the first index. And we would find it right here, because this function would check for the word the at this index onwards in the before string. And we would find it at this index. So str would return and before. It would return a pointer to this location in our string. At this point, we'd increase occurrences by 1. We would increase I by the length of the old substring, and that would put us right here. And at this point here, we would keep checking through the string. We would keep checking through the string 1 character at a time though, because now when we go to check to see if the word the is found in the before string at this index, we're going to be getting no each time up until here. When we find the other the, again, we'd increase the occurrences. We'd skip ahead by that length of the old substring. We'd end up here, and we keep checking through the rest of the string 1 character at a time. So that's what this code here is doing. Now we still need to allocate space for our after string. But now we know how many occurrences of the old substring there are in our before string. And we can do some math now to figure out how big does our after string have to be? So the first thing we're going to find is the difference in length between the new substring and the old substring. And we'll say int subdiff is equal to new length minus old length. So now we're going to figure out the after length. And we'll do it one step at a time here. We'll say int after length is equal to the before length initially. And now what we're going to do is account for the difference in length between the new length and old length string, as well as the number of occurrences of the old substring. So next we'll say after length plus equals, and we'll multiply occurrences by the difference in size. So what we're doing here is we're adding to after length the number of occurrences multiplied by the difference in size between new length and old length. And you can see how this is going to work out. Because if new length is larger than old length, that means we need more space. And subdiff is going to be a positive number in that case. And it's going to be the difference in the number of characters between new length and old length. And then we're taking that positive number and we're multiplying it by the number of occurrences and we're adding it to after length. If new length is less than old length, so our new substring is smaller than our old substring, this number is going to be a negative number. It's going to account for how many characters less the new substring is than the old substring. And we'll multiply that number of characters by occurrences. But because it's going to be a negative number when we add it to after length, our after string is now going to be smaller. So now what we'll do is allocate space for our after string, taking into account this after length. So here we'll say after is equal to malloc, and we'll say after length plus 1 for the null terminator, and we'll multiply it by the size of a character, which we know is going to be 1 byte, but again, we'll just do that anyways. So now we've allocated enough space for our after string. And now the next step in our algorithm is going to be to actually build our after string by substituting in this new substring wherever we encounter the old substring in our before string. So we'll make a couple counter variables here. We've already got a counter variable I. We'll make another one called j, and we'll say int j is equal to 0. We'll also set I equal to 0. And what we're going to want to do is something very similar to this. We want to loop through our before string using I. And again, whenever we encounter the old substring, and when we encounter the old substring, we're going to have to pay attention to the lengths that we add to our counter variables I and j, which are going to be helping us keep track of our positions in the before string and the after string, respectively. So down here, I'll say while I is less than the string length of the before string. And again, we're using I to loop through the before string. And here we'll say if str, and before it I, and old substring works out to be the same position in the string before that we're currently at with index I, then we're going to do something special here. So str, again, it's going to return a pointer to the location in the before string where old substring is first found. And if that position where it's first found is this index I where we started looking from, then we found the old substring at the position I. And what we're going to do in this case is we're going to copy into our after string, not the old substring, we're going to copy into it the new substring. So we use the string copy function that comes with the string.h library to do that. So here we'll say string copy, and we're going to copy into the after string at index j, the new substring. Because the counter variable I is keeping track of our current index in the before string, but the counter variable j is going to keep track of our current index in the after string. And they need to be different because these strings are going to have different length potentially if the old substring does not match the new substring's length. So here we're copying into the after string at index j, the new substring. And now we go to adjust I and j, we're going to account for the difference potentially in the lengths of the new substring and the old substring. So here we'll say I plus equals the old length and j plus equals the new length. So again, just as before up here, we're adding the old length, the length of the old substring to I, because we can now skip over that many characters when proceeding through our before string. But we're going to add to j the length of the new substring, because we want to move that many characters ahead in our after string that we're building our new string inside of. Otherwise, if we didn't find the old substring at this index in the before string, then we're going to do a bit more of a simple copy of one character. And we'll say after at j is equal to before at I, and we'll increment I by 1, and we'll increment j by 1. So this logic will build the after string. And again, I think this is a bit tricky. Let's just go over it with an example. If we did have the cat chase the mouse, and let's say we want to replace the with that, what we would be doing is initially having I and j both set to 0. But we want to build a new after string down here. And we know in this case that the strings are not going to be the same size. We're going to end up with the cat chased that mouse, and that this string here is 2 characters larger. That's being accounted for right here when we're doing this copy and building of the after string from the before string. Because what's going to happen is, initially in our before string, I is going to be at this index right here. And when we're making our after string, j is initially going to be at that first index. But what's going to happen is I and j are not always going to be the same. Because when we identify the old substring in the before string, we're going to increment I and j by different lengths. So for example, we find the word the at this first index here. And we would put that into the after string. Now at this point, we're going to increment I by the length of the old substring, which is going to be 3, and I is now going to be here at this position. But we're going to increment j by the length of the new substring, and j is going to be here. Now as we continue to look at the before string, we're not going to find the word the for a while. So here we'd have a space, and we wouldn't find the word the there. And so what would happen instead is we would copy over the one character from the before string to the after string, but we're taking into account the different indexes that we're now using in the after string and the before string. So we'd copy in the space and the C and the A and the T, and I and j would keep on incrementing, but I would remain, one character behind j. And this would keep on going until we reach the, and then again, we'd have a 1 character difference accounted for. So that's the logic of what's going on here. That's why the copy works. Now there's one more thing we got to do. We do have to add onto our after string the null terminator to terminate the string. And so we'd say here, after at j is equal to the null terminator, because j will be set to the last possible element in this character array after, and we're going to store at that element the null terminator to end the string. And then we'll return a pointer to the string. So we'll say return after, and we'll return a pointer to that string. So the next thing we're going to want to do is test this function out. So we'll go up to our main function here, and we'll now create a test string. So we'll say here car string is equal to hate the sin, love the sinner. And then what we'll do is try to replace the word the in this string. So we'll say here car star result is equal to replace in this string the word the, let's say with the word initially. And then we'll do a printout of the before string and the after string. So we'll say here printf before %s/n, and we'll output the before string, and we'll have a printf with after, and we'll print out the resulting after string. And here I've got to say string and not before, because we called it string. Now when we're done this, we are going to free the resulting string. And the reason is we dynamically allocated space for it. And now that we're done with it, we want to free it. So that way that space could be used again. So we'll save this now and we'll give it a test. And we get build failed. So let's see, we must have a bug in there. We wrote so much code that there must be some kind of bug. And it looks like a relatively simple bug to fix because it says use of undeclared identifier I. And I think what happened was I declared I inside of this block here, this else block. And so this variable here has the scope of this block. If I want to use the variable I again, I could just declare it here and just say int I. So I'll save this and we'll run it. And it says build succeeded now. So we'll scroll up here. And now it says hate the sin, love the sinner, hate a sin, love a sinner. So it seems to be working. Let's try it with the word that. We'll say that. We'll save it and run it. And now we get hate the sin, love the sinner, and hate that sin, love that sinner. So it does seem to be working. We could try one more thing. What if we tried y? And we'll save this and run it. Hate y sin, love y sinner. So it seems to be working when the new substring is larger than, smaller than, or the same size as the old substring. And so at this point, we can be pretty confident that our function works. And so this is how we can build a function in C to replace all occurrences of a substring in a string with another substring. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.